All right, so this is 6.4 lecture videos. I'm gonna do several examples showing you guys how to solve rational equations. We're gonna start with easy example, get into a little bit harder ones, and some harder one down here. Um, it's pretty much what we've done so far up to this point is learn how to factor rational expressions, learn how to find common denominators, and then learn how to simplify rational expressions or complex fractions by times by LCD. And we're going to put all of those concepts together and apply them to an equation, and we're going to solve it. And one thing it's gonna come up quite often is know when the problem is asking you to solve for an equation or the question is asking us to add or subtract rational expressions. So I think that's important to make a note of. Is the question asked to combine these rational expressions, or is it asking to solve? So when you see equation, you see the equal sign. So that's how you know if you're supposed to solve, and using the instructions that solve there. Okay. So here's the 4 steps that I have written down here when you solve any rational equations. First, you list any values that the variable can result in a 0 denominator, and these will be not solution to the equation, because if the denominator equals 0, those x value that makes the denominator equal 0 it's not gonna be part of the solution, because you can't divide 0, right? You're gonna get undefined as part of the term, one of the terms in the equation. And the second step is multiply both sides by the LCD. So this is the important part. This is what we done in the previous lesson, is know how to find LCD for rational expressions. And then we solve the equation, and then once we solve the equation, we want to double check is our answer same thing as any omit values that we list from part 1 there. Okay, so let's start with example 1. Okay, a little bit easy example. So this can be solved, just traditional method, not quite, the rational equation approach, but for the sake of it, let's just solve this using the LCD method, right? So there's no x in the denominator, so we don't have to worry about any possible undefined values of x. So in this case, we're just going to go ahead and times the LCD. In this case, the LCD is going to be 6, because we got 2 there, we got 3 there. So 2 and 3 both go divide into 6. So we're going to take each side times by 6. Okay. So that will give us 3x plus 12 equal 6x minus 2. Subtract the 6x on the other side, so that give us 3x there. So subtract the 12 on the other side, that give us negative 14. So therefore, x equal to 14 over 7, right? So that's how you find the LCD for an easy one like this. All right, for the hard one like this, we do have to identify some of the values that makes the denominator equal 0, which potentially omit that from being part of solutions. So in this case here, these are the denominators, so the values of x. So first we want to factor this. Okay, so we want to say, okay, let's rewrite the denominator and see what are the potential bad values of y here. Okay, so by factoring the denominators, we see that the value of x that makes the denominator equal 0, for this one, we got 0 there, we got 5. This one, we got 5, we got negative 5. So y cannot equal to 0, 5, and negative 5. So these are the omit value. These can't be solutions. These can't be a part of the solution. All right, so that's just something we keep in mind, so that way if we happen to get one of these values as part of the process of solving this equation, we can just make a note, okay, wait a second, this is undefined at these values, so this equation doesn't have the solution. So right, so let's just go ahead and solve this. Okay, so the next step is time both sides by the LCD. So using the technique we learned from previous lesson to find the LCD of these two denominators, we're just gonna look at let's see here, LCD. We want all the factors. So the first denominator has a y and y minus 5. The second denominator already have y minus 5, so we don't have to write twice, but we're missing a y plus 5. So that's gonna be the LCD. So if we take this equation times by the LCD, And the LCD is y times y minus phi, and then y plus phi, right? So when we distribute this to each side, all right, the denominator gonna cancel out. So first one is y minus 4 times y plus phi remain equal. Excuse me. The second one, the y minus phi, y plus phi cancel out, so we get 2y. Then we can simplify this left hand side. Phi plus y minus 20. We subtract 2y to the left. And then we factor. Okay, we solve. So we solve these two factor and we get two answers, y equal 5, y equal -4, and then we go back to the omit value. So one of the omit value was a phi that can't be part of the solution. So we say that this here is solution, this here is a bad one, this is the, can't, y can't equal to phi, right? Because it makes the denominator undefined up here, right? When you plug in phi. So this is the only solutions. I'll let you to check that on your own. Okay. So here's some more example. I'm just gonna go ahead and just let you guys work on this one. On the LCD in this case is x minus 3. So you want to times that to entire equation, x minus 3. Don't forget to distribute when you times that. In this case, the LCD will be x plus 3 and x minus 2. Okay, I'll let you guys work that out. Okay.